Alright, so in this lab, apparently they don't want us to do the entire lab, but then they just want us to submit our simulation files. So there are 4 parts to this: inverting amps, non-inverting amps, summing amps, and the differential amps. So in this first part, what we have to do is select one out of these 4 sets of data and then construct this entire circuit and then submit the simulation file. So what you so basically you don't have to fill this table or not even this alternating current table. We just have to fill up the um you just have to make the simulation and then submit this section. Okay guys, so for this lab session they want us to make this inverting amp, and we use a 741 inverting 741 op amp. 741, you put it somewhere here. And then if you don't know what these pins are, so for example we don't know which one is plus and minus for the power supply, we click on detailed report and then we scroll down for the pin layout, and here they say VS plus and VS minus are 4 and 7. So 4 is minus and then 7 is plus for the power supply, and 5 and 1 we don't use those two. So we get ourselves a voltage supply, DC power, and we put it somewhere here. Negative end goes the positive end goes to 7, and then according to the PDF we want the V in going through a resistor into the negative terminal, negative input here. Control W, resistor, and then we put it down here, and then we have to put another resistor between the output from pin 6 into the negative of the pin, negative of pin 1. Control W, resistor again, pin 6 into pin, this negative pin, pin 2, and then you set you take 2 random values from the data sheet, from the lab PDF. One for example the R1 values range from 1 to just all 1 kilo ohms, and RF values range from 1 to 10 kilo ohms. For this example I'll be selecting RF, which is R2 here, as 10. That's 10 right there, and then V out will be taken from here. So to take V out, I'll take a multimeter for this here, and then the plus will go into this, and then the minus will have to go into the ground. And then here we'll put this into VCC. There you go. Now we'll leave VCC at 15 volts, sorry 5 volts. Now just leave everything as it is, sorry, yeah. And then this plus is supposed to go to the ground. Once again, ground, put it down there, and then this should be ideally the circuit. So input goes into the negative terminal, +1, the positive terminal goes straight into the ground. That's the inverting amp. So what happens when you play this and then pause it? Minus 25.024 volts. That's our value for the output voltage. So that's the simulation for part 1. So I have said You don't have to do this entire table. You just select two random values and then do it. This one also no need this table as they told in the lab session. And then we move on to part two, a non-inverting amp. So similarly, we once again build this entire circuit. We leave the power supply as it is and output also as it is. And as you can see, the non-inverting, your Vin is directly connected to the positive input. Which means this goes right here, and this thing is connected to the ground through R0. This is not supposed to be here. And this one joins to the output here. Once again, you can select two values from this table and then measure the output voltage. So since I have set this to 1 kilo ohms and 10 kilo ohms already, I'll keep it as it is. 1 and 10. Run the simulation and then see what happens. So this is now 55 point. It's changing. Why is that? So it looks like we have a glitch in this program. This thing goes to kilovolts. That's 11,000 kilovolts. So I think the first few seconds are the actual answer. So yes, this thing has its error. So 55.007 volts is what happens when you apply 5 volts of DC to this setup of non-inverting amp. So imagine that we change this value. So say that we put 2.2 kilos just to see what happens. See, this value is low. So similarly, you can select whatever, you can set whatever the value you want. And then you submit your lab. And that's part two. So same as before, you don't have to do this part of the lab sheet. And then part three, the summing amp. This is slightly different. So once again, we save this thing. So layout changes again. Output is still the same. And these two are supposed to join to the same terminal, this negative terminal. But, I know that. Ground is supposed to go there. And then yeah, careful with this minus and the plus. In the top one, it's plus on top, and the bottom one, it's plus on the bottom. So just careful with this thing. 1 kilo ohms here. Goes to the same terminal. And they want us to select two different values for R1 and R2. R1 has to be, one of them has to be 10 and the other one has to be 47. So with this to 10, 47. RF is to be 10 again, 10. It's a V2, that means the one going through R2 has to be 40, has to be 5 volts. 5 volts through 47 kilo ohms. So 5 volts through 47 kilo ohms. So let's make this VCC1. So we can add another one. And then we label this VCC2. So the thing that happens if you don't label this is that when you add this thing, it becomes VCC by default and it overlaps with the previous one. And that will cause a bunch of issues. So to stop that, we label these two like this. And then 12 volts is supposed to go through V1, that is R1. R1 happens to be 10 kilo ohms, 10 kilo ohms, 12 volts. And then we run this. And then we take this reading as a negative 12.103 volts at this. That's the third part of the lab. So and then for part 4, what we are do is the differential amplifier. Say this again, 3.4 minus on top, plus on bottom. So ground has to go through a resistor. V1 R2, that means V1 has to be 50 millivolts. Let's take this as okay. First let's set up the resistors. Everything has to be 10 kilo ohms. 10 kilo ohms sorted. And one of them has to be, let's take the negative one as V1. We need to swap this out. That's the correct circuit, I guess. Yeah, that's the correct circuit. This one has to be V. So the one going into the positive input has to be V2, and V2 is 100 millivolts. And then the one going into the negative terminal, that's V1, it's 50 millivolts. Here, the top line. And then, as usual, we run the circuit and then check the reading. 52.224 millivolts. So that's the result of part 4. I think that's all for this step. Nothing much to do really. Once you set up one circuit, that means the first round, you could just keep on going, pressing save as, and then repeating and then moving on to the next round. So, any questions, guys? Hello?
Yeah, no questions.
Anyone else? Aruna?
No, no, sir. Shit.
For sure, right? Alright. And that's pretty much end. That's pretty much the end for lab